Now, one thing that we come across in probability is we need to know what we call the sample space. It's a layout of every single possible circumstance that we've got available for us. And sometimes drawing diagrams will help us to understand what's available. For example, if I was to consider tossing a coin 3 times, and I'll list out all the possible situations for that. Now, a very easy way to do it is the tree diagram. Here's how we do a tree diagram. Start from a point here, and then from there, spread out to all possible outcomes. So if you toss a coin, the only outcomes are a head or a tail. So if you did one toss of a coin, there are only 2 outcomes, that outcome or that outcome. But what if we now go to a second toss? Well, if you had to toss the head first, on the second toss, you could have toss a head second or a tail second. But if you had to toss the tail first, you could have also tossed a head second and a tail second. So now if I toss a coin twice, there are 4 outcomes. Head followed by head, head followed by tail, tail head, tail tail. 4 branches here, 4 possible outcomes. So of course, if I now add in the third trial, from each of these endings I now branch out into all new possibilities. As you can see, you toss a coin 3 times, there are 8 possible outcomes, and you could go through it and list them out. Head, 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 tail, head, tail, head, head, tail, tail, and on you can go. And then you can start doing your probability calculations from that. Tree diagram, simple and straightforward. Now I'm going to show you a variation on the tree diagram which will make some questions a little bit easier. So let me just get it set up over here, I'll be right back with you. So here's our situation. We're going to roll the dice twice, or 2 dice at the same time, 1 dice 2 times after each other. Same situation. And we're going to look at these 4 questions. And as you can see, each of them are only talking about rolling the number 6. Now, if I was to do a tree diagram like this one could get very messy. It would end up looking something like this. So on the first roll, you can get a 1, 2, etc. Then, on the second roll, from each of these branches, you'll branch out to all 6 brand new options. That's just getting too much to finish off. Because I'm only interested in the 6s, I can simplify this really messy tree diagram down to something much more simple. Watch this. Now, have a look at this situation. I've simplified it down to 2 possible outcomes at each branch, because I'm only interested in looking at getting a 6. So when I roll my die, I'm either getting a 6 or I'm not getting a 6. I've simplified it down to the same as a coin toss. But doesn't this imply, because there's 2 branches, 2 outcomes, therefore this has a 50% chance and this has a 50% chance? Well, it sort of implies that. So what we do to get around that, because this has a much greater probability, I write the probabilities on the branches. So when I roll my die, probability of getting a 6 is 1/6. Not getting a 6 will be 5/6. I then branch out into all new possibilities for the next roll. 6 or not a 6. Once again, 6 or not a 6. And I go through and write the probabilities on those branches. I now have all the information I need to answer these 2 questions. So the first one, probably getting a 2 6s. Trace that branch. Here's this top branch. 1/6, 1/6, times them together. 1 on 36 is your probability. B, probability of getting 1/6. Now I'm just going to list out my sample space over here. It's going to help me with B. So I can get a 6 and a 6. This branch is a 6 and not a 6. That's a way to notate not a 6. This branch is not a 6 followed by a 6. And this one is not Not. So probability of 1/6. Is that only 1/6? No, that doesn't count. This one? Yep. This one? Yep. This one? No. So, these are my two outcomes. If I work out the probability of that, work out the probability of that, and add them together, I've got my answer. So this one is this branch. 1 on 6 times 5 on 6. On 36. This one, it's the same, just in reverse. It's another 5 on 36. There's my probability for D. 10 on 36. No 6s. The only option is this one down here, which is 5 on 6 times 5 on 6. Now D, at least 1/6. At least 1/6 could be 1/6 or 2 6s. So that would be those three situations there. So I'm going to do the probability of that, plus the probability of that, plus the probability of that. Or I could do complementary events, which would be everything is probability of 1, take away this probability here, which I've already worked out at 25 on 36. Final answer is going to be 11 on 36. Complementary events made this a much, much easier situation. So there's tree diagrams. They can get really messy if there's lots of branches, but you can often simplify it down by taking this approach where you write the probabilities on the branches. So good luck with that. Now, by the way, just letting you know that apparently tomorrow at school is going to be Jamaican Hair Day. I'm dreading it.